Oh, yeah, similar, not quite the same. Oh yeah, that's what you didn't reduce. That's why, yeah, I got hit.
Can you answer one quick one? Super easy.
I got hit right here because I didn't reduce. And I got hit right here because C's not by itself.
Yeah.
So the one I agree with is 3 minus 4 is negative 1 is minus 1. And I know you
Yeah,
get the
me
same
too.
answer,
Mine's like
but you're not doing it. You just got lucky.
At least you got like when you get.
Mine might be like you're like halfway.
That's what I got. I got 76. Yeah, that's like a freaking.
Yeah. What's the absolute value of 2 minus 7? Yeah, 2 minus 7 is negative 5. And then the absolute value is 5. This is not equal to 2 plus 7, right? I can't take an absolute value of a piece of a number. I have to know what that whole number is first before I can then take an absolute value. So be careful about that. Don't just change any minus you see into a plus. That's not right. You can't apply the absolute value until you have the number. And at first I don't have the number until I actually put them together. So you can't just make that a minus into a plus. Cool. Okay. So absolute value is acting a lot like parentheses. You do what's inside first, force it to be positive, and then you do the rest of the stuff around it. Okay. We're going to finish up chapter 2. We didn't finish up chapter 2 before the test.
No, there's no 2-7. No, that's for a different question. I listen.
No, 2-8 is where we stopped off, yeah. 2-7, I don't think that's in my...
No, it's not.
No.
See?
It's not in our curriculum. 2-7 is a section that you're going to do when you go to 103 or 110. Whatever you do next, that's the kind of word probably going to cover there. Okay. 2-8 is something. Let me start off with just what you guys know about this. I think we talked a little bit about this kind of stuff before. What does that say?
Greater or equal to.
I saw in the problem set when they said like 7 less than a number.
Yeah.
How do you write 7 less than a number?
7.
X minus X.
That's 7 less than a number. How do you write 7 is less than a number? 7 is less than a number. So when they say 7 less than a number, they mean subtract it. 7 is less than a number, that's the inequality symbol. Right? Because that's how I read this. X is greater or equal to 3. Cool. So how would you... And then another way I remember this, I'm sure you guys have all heard about like the alligator wanting to eat things.
Lazy L.
Yeah, it's in lazy L. Did I already say it before?
Yeah.
That's a lazy L, that's less than, right? So L is kind of like, oh man. And then that's greater than because it's yellow. How do I graph this thing? Well, give me an answer. Give me one answer to this. Give me one answer, because what does this mean?
Oh, you circle the shape.
So that's how I showed all the answers. Somebody give me one number that works here. Give me one answer.
2.
Like,
Oh,
3
sorry,
works.
3. Yeah.
2 is kind of going at 4. So my graph, and how many answers are there? Infinite number. So instead of listing them, because that would take the rest of my life and everybody else's life forever after me, we're going to make a freaking picture and say, if you want a specific one, you go find it yourself. That's why we graph. In fact, we're going to get into chapter 3, which is going to be the graphing section, which is normally people's most hated right after word problems is graphing. But one reason we graph things is because there's an infinite number of answers. Do you want to list it? No. Let me make a picture for you. Cool. That's one reason and that's totally honest. That's exactly why we do it. Another reason is just to see what the hell it looks like. But what would I have to definitely have down here? So I can put a 0, 1, 2. I definitely have to have 3. There's no question about that, right? Because 3 is the main dude here. One side of him is going to be answers, and the other side is going to be not answers. What goes on the 3?
A solid circle.
All right. So for right now, I'll accept that, and we're about to talk about what you should put on there now. Right? So what you've done in the past, you put a solid circle. Why is it solid?
Because it's also equal to.
I love it, because you shade where all the answers are, and 3 is an answer.
And then you put an arrow going.
Yeah, so whatever your teacher told you, I normally just do this.
Yeah.
Some teachers, I'm sure, maybe told them to put it overhead. We're not going to use a closed circle like that anymore. We're not going to use an open circle anymore.
What are we using?
Yay. We're going to use something that's related to something called interval notation, which is it's a more compact way of writing the same thing. It's not visual, but it's still really quick to write. So we wanted a direct connection between the two. There's no circles in the other notation. So what does this mean really? That means that I'm going to do what with the 3? That I want to do what with it? Here's all my set of numbers. I want to include it. I love it. You said exactly the word I hope. So this just means, include. Right?
Yeah.
And this, of course, means exclude. Don't include, right? How are we doing so far?
All the numbers above. Yeah.
Because if I didn't want to include it, then I would have put an open circle on it. Does that sound familiar?
Yeah.
You guys remember that? Some of you guys might have used the symbols I'm about to use. If you did, cool. You're a little ahead of the game. I love it. Instead of a closed circle for include, here's the letter I for include, right? I'm going to use this. A bracket. A hard bracket. Instead of a circle for exclude, I'm going to use this. A parenthesis. You guys see I'm trying to give you a way to remember which is which. If you want to include it, use the one that looks like part of an I. It's got the hard turn, right? If you want to exclude it, use like an open circle cut in half, right? So here I want to include it. So the way I really should do this is have a bracket like that. How are we doing? So it's not a major change. I'm just saying instead of putting a little ball that's filled in, put this little symbol there. Exactly. So it opens up in the direction you're shading. So if it was x less than 3,
Bracket the other way.
let's say something more interesting. Let's say x less than -2. So it's less than. Do you want to include the -2?
No. You want to include
So what would you normally put on it? You would normally put on it
an open circle.
open circle. So now you put
C.
part of an open circle. You put your C, yeah. And which way do you want it to open? Which way are you going to shade? And here's the cool thing. If your variable's on this side, that is an arrow that points in the direction you shade. I don't know if you guys have been told that or noticed that.
What?
But do you see it now? If you have your variable on this side, this points in the direction you want to shade. I can't get any better than that. It's telling you. It's not, hey, dude, shade that way. You know, I can't do any better. So on the -2, we're going to put a parenthesis because I don't want to include it. And I'm going to shade this way because that's where things are less than -2, right?
Is this how we're going to write it in higher math, or is this the way you want it?
This is the way that you're going to write it from now on.
Okay.
Yeah. It's not just me. I'm trying to get you guys ready for the next levels.
That's why I said, this is
Yeah.
what we're doing.
This is it. Cool.
So you do that handshake,
Yes, exactly.
but on the bracket you don't have to shade?
Did I not shade? Yeah, you
Oh.
shade. Bless you. Yeah. Say again?
So if you're excluding the number and then use it.
Yes. Oh, exactly. Exactly.
Same thing as the
So here's the difference. Well, let's do a couple more of these, and then I want to show you something that might be new to a lot of you guys. How many of you guys have ever heard of what I said earlier, interval notation? How many of you guys have ever heard of that? Okay, so let's focus on this for a minute before I show you this new stuff. The cool thing is it's new, but if you can draw the picture, it actually comes right off of the picture now because I'm using the right symbol, getting me ready for interval notation. That's why we changed the symbol up. These circles don't help me out worth anything. So screw them. Let's use something that's going to help me out for the next step. And interval notation is what you use most often in higher level math. You use the interval notation instead of making this big old picture. Yeah.
What's the difference between the first one and the second one?
They mean the same thing, except now we want to use this symbol. We want to get away from this symbol.
Oh, so
That's
we
all.
have to use that.
They mean exactly the same thing, except I don't want to see
I
that.
don't want to see that.
I need to see
So they're
this.
different. Okay.
Cool. But I want you to understand, it means the same thing.
Same thing.
Cool. How would you do this here? What's another way to read this? Where are your numbers? Where are your answers? They are in between. I love it. It's exactly the word you want to think of when you see this. Everybody breaks it down and says it's got to be less than 11, and they go too far. It's got to be in between 7 and 11, right?
But you want to include 7.
So how are you going to graph that then? Obviously, you need to have 7 on there and 11. What symbol goes on the 7?
The bracket.
Bracket. And where are you going to shade? Where's in between? Maybe we should start there. Yeah, here. So which way should the bracket be showing? This way.
Yeah.
And which way should the parenthesis? Because that's not including,
The
right?
opposite way.
So we're going that way. So again, if you have trouble, and again, if this is brand new to you guys, these symbols, just do what you normally would do. Put a circle there like that. But then erase it and think, okay, I want to include it, so I better use the one that looks like part of an eye for include. If you want to put an open circle, just put a big-ass half open circle, right? That'll be your parenthesis. So it shouldn't be that hard to kind of remember which one goes with which. That's my hope. Okay. Maybe. But some of you guys might be looking at this and saying, why didn't you shade down, Jeff? And that actually relates to some question I just heard a second ago. So let's look at that by itself.
7 is less than or equal to.
Is my variable on the correct side to see this quickly which way to shade? If 7 is less than or equal to x, give me a number that works.
7.
6, no.
7.
8, yes. 7 is not less than or equal to 6, is it? Do you see how it's backwards? That's why I said the variable, if the variable's on this side, it's easier to do. So how would I shift this whole thing around? If 7 is less than or equal to x, x is greater than or equal to 7. And isn't that exactly what this piece says? But when it's written like this, it's just easier to think of it's in between. And then you kind of contain it. But I really wanted to break this piece down. So I saw some of you guys like, why the hell is he going that way when it says to go that way? Because my variable's in the wrong side for that piece. Right? If 7 is less than, x is bigger than. So it makes sense. Okay. Here, let me give you a couple to try on your own real quick. Do this one. Let's see. That's a 12. Yeah, do these. Yeah. Bless you. See, you don't have to always start at 0, right? Don't drive yourself crazy either drawing these big number lines or lots of little tick marks. You can start. Just make sure negative 12 is in there and then maybe a couple around it, right? That's beautiful. I love it. You don't have to have 0 on there always. So let's see, what symbol should we use? The hard bracket, not the parenthesis. I love it. So I'm going to officially call this a bracket. I'm going to call that a parenthesis, so we can I don't remember what's going on yet.
Can you explain that one time which one you know how to use the next time?
It's just because this is the same as a closed circle, right? And this is the same as an open circle. The way I gave to remember that.
Well, I mean, what do those mean though? The closed empty circle.
Oh, okay. The closed circle meant that you would include that,
Okay.
right? Because if I had something like this, 0 and there's a circle on it and going up, does that mean 0 is an answer? No, because you shade where the answers are, right?
Yeah.
So if I want 0 to be an answer, I have to shade it also. So a closed circle means you shaded that thing. That means you include it. And doesn't that symbol look like part of an eye?
Yeah.
Cool. So that's how you remember what to do, right? Open circle means you don't want to include it.
Right. Yeah.
All right.
So the symbol.
Is it allowed to equal it? Then you want to include it. Is it not allowed to equal it? Then you don't want to include it. Cool.
Yeah, that answers
Is that cool? So really, it's all about if there's a line there, it means it's allowed to equal. If there's a not a line, meaning it's not allowed to equal.
So if it's equal,
Then you want to include it. It's going to be the closed circle what it used to be, and now it's going to be the hard bracket.
Okay, so if it's included, it has the greater than equal?
Or less than equal to. It's just got to have that equal to in it, right?
So we're shade that way.
Because another way I heard one of my students say was they think that hard line, and then they think the one with the hard line in it, right? Yeah. That's another way to look at it.
So then, excluding would be just the
Parenthesis. The soft parenthesis,
and
yeah.
it'd be just greater than or less than.
Exactly. There's no equal to sign in it. I love it. Good. I like it. So when that's a good point here is when you ask me a question, don't give up if I don't answer your actual question. Try to, because I don't sometimes understand where I'm losing people. Yeah, so, cool. So what symbol here are we going to use? The bracket. And which way should it face? Because it's going to shade that way, so it better face that way and go up that way. Is that cool?
Yeah.
So far, so
Good.
okay. Good.
I like it.
This guy, and again, I don't care how much you show me. You definitely have to have -1 and 0 in there.
Yeah.
What symbol should be on the -1?
Bracket.
And what symbol should be on the 0?
Parentheses.
And where are you going to shade? In between. All my answers are in between -1 and 0. So here's my answers. They're in between. Don't include the 0, but definitely include the -1. Don't let yourself get confused about, I'm not going to know. X is bigger than -1. Doesn't this say X is bigger than -1?
Mm-hmm.
But it also has to be less than 0. Isn't it less than 0? So that's what, it's got like a ceiling and a floor, right? Don't go below -1. Oh, but don't go above 0. Oh shit, so I'm contained. So I always think of it as like a sandwich. Or a sandwich, right? But a good sandwich is a sandwich. So it's been sandwiched in between these things. That's how I think of it. It's been contained in there, right? Yeah.
You said include. What do you include?
The actual number itself. So does -1 work? If I plug a -1 here, is it true? Yes, -1 is less than or equal to -1. If I put a 0 in, does it work? Is 0 less than 0? No, so I don't want to include it because it doesn't make it work. Good, good, good. Sweet. Yeah. Sorry. I like it. Yeah, what does X mean? Where's X on this picture? It's everything I shaded. And the bracket here too, right? X is a variable. It can be anything it wants to be, except here, do you see how it's not allowed to be anything it wants to be? I'm saying X can only be in between -1 and 0, not including 0. So that shading actually kind of represents my X. Please don't do this. Right?
Right.
Because you can't find X. What is X? X is a lot of values in this case, because there's a lot of things that's greater than or equal to -12. So you can't pinpoint it. It's everything that's greater or equal to -12. And we know that X could be almost anything. Here we're just kind of like putting restrictions. No, it can't be below -12. It's got to be greater or equal to -12. Okay, maybe. So you guys are still looking at me like I'm crazy. So here's the next level of this. Let me start here. This might be a little easier to see. The next level of this is called interval notation.
I remember this.
And the basic idea is it's smallest to biggest. And you use the same symbols on the outside that you did on the numbers themselves. So for example, what's the smallest thing that I'm including up here?
-0.9.
Well, -1.
Yeah.
And I know I'm not including 0, but what it still goes up to 0 almost, right? Well, what symbol did I use on the -1?
A negative. Oh,
What symbol?
Bracket.
A bracket. What symbol did I use on the 0?
Parentheses.
That's interval notation. So how do I read this? From -1 to 0, not including 0. So it's even a little quicker than the picture. That's why in higher math we use this. You know, some functions I'm only allowed to use certain values. So for example, if a rocket goes up and after 8 seconds it crashes, I can't say, well, where's the rocket at 10 seconds? Well, it's on the freaking ground. I can only use from 0 to 10 seconds, right? So I'd say from 0 to 10 seconds. So I'd say to somebody, you can use anything from 0, I'm sorry, 8 is when it crashed, right? To 8 seconds. That's the only time you can ask me about, because after that, it's on fire on the ground. So leave me alone, right?
So we can do either, when we're writing answers, you want both
I'm going to ask for both, because we have to get practice with both. And I'm telling you, in later math, you're going to mostly use this to describe what somebody's allowed to use and not allowed to use. Yeah. So let's try this one. Now, this is where it gets a little freaky, because this one had a floor and a ceiling. Is that cool if I say that?
Yeah.
It's connected on both sides. This one, what's the smallest it could be?
-12.
Negative 12. And what symbol is on that?
Oh, the bracket.
See how that's nice now?
Yep.
Yeah.
Just whatever there is there. If I had a circle there, I'd be, oh, no. Whatever's there is there. What's the biggest it could be? I love it. Not X. Because again, if you say X, that's kind of weird. X is everything. It goes up to infinity. Now, how are we doing? Because when does this stop? Never.
It never
And that's basically the definition of infinity. It just never stops. What symbol should I use on infinity? No, it has to have something. If I use this symbol, and see how I'm not drawing it, so it's probably the wrong answer? That means I can include infinity. That means somehow I found it. Well, there's infinity. Oh, cool. Can I find infinity? That sounds like finding nirvana, but
No.
I can't find infinity. Give me the biggest number you know, and then double it. Uh-huh. And then double it. You can't get there. So you never use a bracket. You always use a parenthesis on infinity. You guys with me?
Yeah.
So really this means like the sky's the limit. It says, you know, there's no top to the sky. It goes from -12 forever. That's what that's trying to say.
So whenever you include infinity, you have to use that.
Yes, whenever you have like one side doesn't have a stopping point. There's going to be infinity on that side. You better have a parenthesis there, or else you better show me how you've reached infinity. You better show me, because then I want to write a book.
Right.
My student reached infinity.
Wormholes.
Let's try a couple more, because this is a little weird. I understand. So I want you, let's see, let's try to do this problem right here. Graph and then interval notation, right? For these two. So graph them and then interval notation them. Make it into a verb. All right, guys, so what, for that first one, what symbol is going to be on that -3? Parenthesis. And which way is it going to face? It's going to open to the, right, good. It's going to open this way. Because where am I going to shade?
In between.
In between. So the x's, all my answers are in between -3 and 2. What symbol should be on the 2? Another parenthesis, 11. Right? Now what about interval notation? Yeah. So you can kind of start with what's the smallest number, -3, what's the biggest number, 2, and what's the symbols on both. I mean, interval notation is easy once you get that graph made. Hopefully I can say that. But you guys see how they directly relate? Yeah. Yeah, it's allowed to equal 5, so you want to include 5. So it's got to be the hard bracket, the one that looks like part of that.
Because I know that the something infinity 5 and then bracket.
Okay, cool. All right, so let's start with that. So which way am I going to shade? Down. And which way, what should be on the 5? Bracket. So see, for the graph, that's all I need. So what's my biggest number? 5. And there's a bracket on it, right? That side's easy. What's my smallest number?
Infinity.
Be careful, that infinity's over there.
Oh,
What's
wait.
my smallest number? Negative infinity.
Oh, you got me.
Yeah, me too, but yeah, it's going to be negative infinity when it gets really big negative, right? And of course, what's always on any infinity? Parenthesis, because you can't get there. Now, once I show people this, I get somebody doing this, just like putting an X on there. What's wrong with putting that there? Because then what would this be then? If that's negative infinity, what the hell's that? It's freaking Buzz Lightyear thing, right? Can't do that. So don't show infinity on the number. There's no way. You can't find infinity on the number line. Because then what's right below that? Wait, that's supposed to be the biggest negative. Wait a minute. You can never get there.
Doesn't the arrow represent infinity?
Yeah, the arrow in a way represents infinity really well, because infinity is a process. One way to think of infinity says start with 1, now add 1, now add 1, now keep doing that forever. That's infinity, right? Yes, ma'am.
So when you have the X in the middle, I understand that means between.
Good.
But when you have, because remember how you were telling us if the arrow's pointing to X, then that's the way
If the arrow, no, if the X is on this side,
on that
I shade
side,
the same way this points.
that way.
So here the X is on this side, that's why I shaded it up, because that's the way it's pointing.
That way.
Yeah.
Okay. So, but then that doesn't matter for that X. You're just doing it
In between, it's
anyway.
easier, because it gets a little confusing, but that's like backwards from what it should be.
Right.
As I'm saying, it's
So
much
just
easier to
ignore
think of
that,
this as a
just
sandwich.
in
It's just,
between.
it's in between.
Okay. So
It's
just ignore
containing.
that rule for that.
It's a shortcut for this. Yeah. Cool. I like it. Okay, cool. Yeah.
When you have like 3 numbers, besides we have like -3 and like 2.
Oh, can I add a third
Yeah,
number?
like
No.
3 numbers and 1 infinity.
You can have another set, but that's getting a little ahead of us. Yeah. That'll be a few chapters down the road. Yeah. All right. Let me ask you this. How many answers are there here?
5,
Be more specific. No.
6, 6.
Just a little bit more.
No. It's -3.
What's this number? Isn't that an answer?
Oh,
Isn't that number an answer? Isn't that number an answer? Isn't that number? So how many answers are there?
a lot.
How many numbers are between 0 and 1?
A lot.
5.
An infinite number. Isn't 0.1 in there?
Yeah.
Isn't 0.01? Isn't 0.001?
Yeah.
If I just keep doing that, isn't that already an infinite number of numbers? Because how long can I do that? For freaking ever. And I haven't even gotten to 0.02 yet. Holy shit. Now, I'm not trying to freak you guys out, but I'm trying to show you how math, the way we set it up, it kind of includes all this neat little kind of side effects of how we set it up. And that's it. Between any two things on the number line, there's an infinite number of numbers. I don't care how close you make the two things. There's always going to be an infinite number of numbers in there. That's crazy.
It's like that half the distance problem, right?
Yeah, Zeno's paradox. You've heard of that?
Yeah, what's it called?
Zeno's paradox.
Yeah.
When our teacher told us that, I don't know if you guys have heard, how can somebody ever get to that wall? Because I have to cover half the distance first. And then I have to cover half of the remaining distance, and then half of that distance, and then half of that distance. I'm never going to get there.
Oh, yeah, I've heard that.
And so my teacher, when my teacher said that, I said, well, just tell him the wall is twice as far as it really is. So when he takes us first, I'm never going to get you're there. Oh, shit. Yeah. So it's a silly, that's where people start to lose faith in math, because they're like, I can get to the damn wall. I can touch the damn wall. Get away from me, you freaky math people. But it's still an interesting thing about how close can you get to something, infinitely close, and still not be there. That's really what this says, isn't it? What number works? 1.5 works, right? What about 1.9?
Yeah.
1.99.
Yep.
1.9. You can get infinitely close to 2, can't you? And again, I don't want to freak anybody out. These is interesting little things about math. How much do we have to know? Just to make this, that's all. You don't have to know all this other stuff I'm throwing at you. Okay, so, as some of you guys might have realized, they're not going to start us off like this or like this. They're going to start us off like, here's the full picture. Section 2A stuff. You start us off like this. So solving inequalities, if you know how to solve equations, you pretty much know how to solve inequalities. There's just one little thing that's freaky.
That symbol.
I like this. You guys are already doing it. I love it. Let me catch up to you. What are you guys doing first?
Distribute.
I love it. 7.
Minus 2x. Minus 8.
I love it. Minus 8. Put your like terms together. Good. Here you get an x, and here you get a minus 1. And see how I can underline like terms with the same kind of symbol that might help some of us see what like terms are? Right, so underline these and then squiggly line those, so you know those go together. Less than or equal to 7. I haven't done anything to that side yet because there's nothing to do to that side. One last step.
Add 1.
Add 1. So you get x less than or equal to 8, and then you can graph it, and you can interval notation it, right? So do that. Yes. We're going to get there. I don't want to do that first.
From negative to positive.
We'll see.
Yeah. Oh no, from divide to multiply.
It's kind of a combination of what you just said.
When the symbols change. Right.
Yeah. Something in inequality sign.
Yeah.
And inequality solving makes the symbols change. Something.
When the symbol changes from a neighbor or a positive, and that's when the sign switches.
Sort of, maybe, not really.
You know I'm right.
Sort of.
You know I'm right. I always have a hard time writing negative infinity. I don't know why.
I know.
I
me
just keep
too.
messing that up.
That sign's
Turn the paper
awkward.
and make it 8.
That's what I
Oh, really? There you go, cool.
Mine's all screwed up.
Alright, so here's 6, 7, 8. So what symbol should go on the 8?
Bracket.
Hard bracket, and shading which way? So it should open this way. So what's my interval notation going to look like?
Open parentheses.
Negative infinity. Yeah, parenthesis on that bad boy.
8 bracket.
Up to 8, same symbol I used.
Hard bracket.
So that's a real quick way to tell somebody I can use any number up to 8. Very quick way to tell somebody that. That's why we use that in higher mathematics, to tell people what you're allowed to use for certain functions. So, here's a big thing. Who remembers the weird thing about inequalities? The one difference in solving them is that sometimes you have to switch that sign. And let me actually start off with the reason. Here's why this works. Which one of these is bigger?
2.
Okay, good. If I divide or multiply both sides by a negative, let's just say negative 1. So divide both sides by negative 1. Or multiply. What does this become?
Negative 2.
What does that become?
Positive 1.
Which one's bigger now?
That was
The 1.
What's happened?
This sign switch.
Okay. So why? Because. And think about it. When you multiply or divide by negative, you change the side of 0 that the number's on, possibly, right? So you change, sort of like what you said, not really, but sort of. You change the side. It's called what's called a non-order preserving thing. When you multiply or divide by negative 1, you've changed which one's bigger and which one's smaller. So of course the sign moves. So I really want you to remember this example. What is a variable then? I mean, what is a variable? So if I have negative x greater than negative 1, isn't a variable just a number? It must act like any other number would. And what do numbers do in this situation when I divide by a negative 1? Don't they make the sign change?
Yeah.
So x is a freaking number that I don't know yet. It's going to make the sign change when I divide it or multiply by -1. So here I get positive x. Here I get 1. And what happens with the sign? Flips. Now, if you will indulge me for a second, I want to show you another reason why this is true. Just to really hammer it home. This is going to seem a little silly at first, but for those of you who like to keep your variables positive, this is not a bad idea here. If I add x to both sides, can I do that? Of course I can. What do I get on this side?
Nothing.
0. Greater than x minus 1. Is that cool? Now I add 1, right? 1 greater than x. If 1 is bigger than x, see how x is on the wrong side? It should kind of, inside you should be going, oh, that's not quite right. You want the x on that side, don't you? If 1 is bigger than x, then x is... So see how if I move the variable to the other side, the sign didn't flip, but the x switched sides. Did I end up with the same answer? Hell yeah. So that's another reason, if you don't do this, you better end up with the same answer as you would if you would have done that. It's got to be consistent. Or else one person is going to say, well, we need to sell less than one thing. You're going to say, I need to sell greater than one thing. You're like, well, who the hell's right? Shit. It's got to agree. It's got to be the same. So, let's try a problem that has this in it. And you guys can do whichever way you want to do it.
Wait, so if you did it the second way, you have to change the sign?
If you keep the x positive, you're not going to divide by a negative number, but the x moved to the other side. You see that?
Yeah.
Whereas if you divide by a negative number, the x doesn't move to the other side. The sign flips. So that overall, you get the same answer either way you do it.
So
I don't want you to forget this. This is the most direct reason why right there. Why does it happen? Because it freaking happens. I mean, that's...
so if the variable moves from one side to the other, you have to switch the sign.
if I want to write this the other way around, I got a mirror reflector, right? Image, mirror image. If 1 is bigger than x, then x is smaller than 1, right? You're not allowed to just move that over there, move that over there. Right? You got to turn the whole thing around. Why didn't that bother us before? Why is that the same as that? Because the equal sign looks the same. So I did flip the equal sign, but then it looked the damn same? Of course, so we never saw it before, but now it doesn't look the same. I got to flip the whole thing around like a mirror image. Okay. All right, looks good so far. Jeff, what do you got? Sure. Make this slightly even.
Yeah, you did.
I do that. I do that sometimes. You're not going to end up with a whole number answer.
No, you're not.
Just in case you get a little freaked out. Well, it's not that terrible. It's going to make graphing it a little bit harder, but not really that bad. It's easy to find halfway points. So what do you get here?
6 minus 2x.
Less than.
Add 7. Or 6, sorry.
So you can subtract 6. Now some of you guys can add 2x and add 7, but then at the end you got to remember to flip it so that you keep yourself straight about which way to shade. So if you don't like remembering when to flip the sign, you can always keep your variable positive. You're just going to have to remember if it ends up over there, you got to flip the whole thing around. So either way you do it, you have something to remember. So whichever way thing you can remember most often, you do it that way. So if I subtract 6, I get negative 2x less than,
Negative 13.
and then I have to
Divide.
divide by.
Negative 2.
I'm dividing by a negative. Therefore, the sign must switch. The two negatives
Cancel.
Cancel, you get 13 halves.
Which is
And 13 halves is right in between what and what?
6.5.
It's 6.5, so it's right between 6 and 7. So graphing this isn't really that evil, right? Whenever you divide or multiply both sides of an inequality by a negative number, you must switch the sign. Yes, when you divide or multiply by a negative number, you must switch the inequality sign. So be really careful. I'll show you an example where people make a mistake with that. But just to finish this out, to graph this, here's 6, here's 7. So 13 halves is right here.
Mm-hmm.
What symbol do I want on there?
Parentheses.
Beautiful, because I don't want to include it. So I want to use the soft, like part of an open circle. And of course I'm going to shade up.
Yep.
There you go.
But how do you know it's between 6 and 7?
Because it is between 6 and 7. Oh, how do I know it? What is 13 divided by 2? You can do that. Yeah, the way I think about it is 12 divided by 2 is 6. 14 divided by 2 is 7. So it's got to be in between 6 and 7. Yeah. Cool. So where people make a mistake is when they have something like this, 2x greater than negative 6. I see this all the time. They divide by 2, and they get that. Now, what mistake was made?
They flip the sign for no reason.
And why is that a problem? They're going to say, well, there's a negative there. You told us when there's a negative sign, Mr. Waller, you suck.
The sign.
I've had people get angry. What you divided by what?
A positive.
Positive 2, so you don't flip the sign. This is wrong. You only flip the sign when you multiply or divide by a negative. There's a negative in the problem, but I divided by 2. So I don't have to flip any sign. Right? I just made everything half as much as it used to be. The bigger one is still bigger than the other one. It didn't flip them around each other. It didn't change your signs. Yeah.
Is it okay if you use 6.5 instead of 13?
It's fine. Sure.
Okay. And so, interval notation, right?
Oh yeah, interval notation for that one would be what? Smallest one is 13 halves or 6.5. Up to what?
Infinity.
Infinity, and you always use parentheses on that. Cool. And this is just a little quick example. Okay. I don't think they get too much worse than that. No, they don't get much worse than that at all. Cool.
Okay.
That was as evil as it gets. Huh?
That's as evil as it gets. There's a couple with fractions in them. But what do you do when you have fractions in an equation or an inequality? If you want to, you can multiply by the LCD and kill them all, right? If you don't want to, you can just use them. I love it. Use the fractions. You don't have to kill them. Use them. Well, because it's good to see people not mortally afraid of fractions. All right, so I just want to do a little bit, and before I forget, there is a workshop this Wednesday and this Thursday on lines, graphing lines. There's a little handout up here. So this Wednesday from 10 to 11, and this Thursday from 1 to 2. You can see the rooms up here. They're both in 36, what used to be 300 North, the one that's right north of the Science Building. Okay. So you guys can see there. They got this in the Math Study Center also posted. I don't know if you didn't get an email about that, did you? You did? Oh, cool. They are emailing people because I am the one that used to do that, and now somebody else took over that job, so I can take over some other job, and I'm not sure what they're doing with it. So just a little bit into chapter 3, and actually the very first thing I want to ask you guys. Well, I can't get too far in myself. The very first thing we have to do is to see if you remember just how to graph points. So if I have, and I'm not doing this to freak you out, but if I have one dimension, that's this. I can only move left and right. That's the kind of problem we just did. And if I said graph x equals to 2, what would you do? Put a dot on 2. In fact, there was something in the homework, I think it was in chapter 1 stuff. Plot these points. You just put a dot. There it is, right there. Yay. When I get 2 dimensions, which means I'd have an x and a y, because now I have 2 directions I can go. It is a lot like, and you hear this all the time, it's like latitude and longitude.
Yeah.
You can find a place by saying go over this much and go up or down this much. Right? That's how you find somewhere.
Like,
I can't find a lot of places this way. If I'm only like, how do I get over there? Shit, I gotta be able to go that way sometime, right? So, two dimensions. What we do is we have our regular x-axis here, right?
Yep.
But then on top of that, we overlay
A Y.
the y-axis. And this really is nice when you're graphing stuff like the equation that governs a baseball. Looks just like a baseball would, right? If this is the time and you throw it, you throw the baseball and you watch it fly. The graph is actually a nice visual of what you would see if you were there looking at it. So very often we use graphs because it directly correlates to what I would see. I have the equations of motion, how it moves, and I graph it, and I'm like, oh, there it is. It's moving like that. You know, so that's one reason why we do it. The other reason I already told you guys. If I graph the equation of a line, it's giving somebody all the answers. Right? How many answers are there to an equation? And I'm getting a little ahead of myself. Let me back up just a second. Do you all know how to graph points like 2, -1? Can you graph? Take a minute, make a rectangular coordinate system, also called Cartesian coordinate system. We would just call it the XY axes, right? Or the graphing area. And just plot these points here. Let's make that 3. So for those of you who want to, you certainly can get graph paper. For those of you who are at least as messy as I am, please, dear God, go get some graph paper. To help me out when I have to look at your stuff. All right?
All right.
Thank you.
Where's the bookstore at exactly?
So if you go out this way and you follow that green thing around, the
Yeah.
bookstore's right around the corner. Isn't it still there?
Yeah.
I haven't been there in a while.
It's up top.
You know where they got that weird pyramid, that rectangle, that metal pyramid-looking thing over there? Have you seen that on the construction?
Possibly. I'm sure if I open up my eyes, I can see it.
That's step number 1.
Yeah.
You're walking like, oh, I forgot the first step.
X's first?
Alphabetical order. You guys hear that? That's a good question. Alphabetical order always, unless they say otherwise. So if I had something with P's and Q's in it, P would come first, Q would come second. Alphabetical order. You don't have to make a grid, no. Unless you get graph paper, and then it will have like a real faded grid, so it doesn't overpower what's going on. Where's the point 2, -1? How do you get there? Where do I start?
You start with X. So it'd be 2 to your...
And I start at this point here, right?
Yeah.
And that's the origin. The 0, 0. So if I go 2 over,
2 to your right. And then 1 down.
and then 1 down. So it is exactly like giving somebody directions. How do you get to your house? So you go 2 blocks over and then 1 down. That's my house right there, the big blue one. Or used to be anyway. That's this whole little story. What about -3, 4? So this is the point 2, -1. 2, -1. -3, 4. So I start here and I go,
Down.
3 to your left.
cat follows X is first.
Oh, sorry.
So back 3,
Up 4.
up 4, right? Positive 4. So this is positive. Let me do this for us. This is positive. And these directions here are negative. Negative. Right? For sure, whatever you say, Jeff. So then -3, back 3 on the X, and then positive 4, up 4. Do you see how I don't put a point in the intermediate step? You put a point at the end spot, right? Where's my house? It's not there, it's up there. So that's the point, -3, 4. What about 0, 3?
You start at 0.
Start at 0.
And how much do I go left to right? None. Good.
0.
I only go 3 up.
And that's it.
Sweet. And that's a really easy point to mix up, right? But 0 on the x-axis. I don't move left to right at all. The second part involves up and down, right? So it's left and right for the first part, up and down for the second part. What about -2, 0? That says to
Oh, -2.
back 2 and up or down 0. So I just stay right there. So there's -2, 0. And I made a cool little tired rhombus thing. I don't know. Somebody sat on it. But don't connect the dots. These are all individual points, right? You don't have to connect these dots yet.
Do you want the interval notations for each dot that you lay down?
Interval notation means that you include all numbers in between two numbers. These are very specific individual dots.
Okay.
I'm not including like all numbers in between. I can't make any interval notation for this because it's nothing like starting somewhere and shading to somewhere else. This is a dot and another dot and another dot.
So do you want those with the...
Oh, I'm with you.
I want them in there with...
Unfortunate thing about points is they look like interval notation, right? These are points. You have to understand what they are based on the context. If I say graph these on a coordinate system, then you understand that they're points, not interval notation. It doesn't mean...
Two is not bigger than...
Exactly. 2 is not smaller than -1, so for the interval, that wouldn't make any sense. But the point 2, -1 makes sense. But it sucks that they have the same symbols. I can't do anything about that. Sorry. I wasn't around when they talked about that.
I just want to know if you want them on the graph.
Just like that. Oh, to put that on there?
Yeah.
I think in your homework they should have like A, B, C. Definitely put an A and a B so I can find them,
Okay.
right? Otherwise you got a bunch of points that look like measles. I have no idea which one's supposed to be which. So the last thing I want to talk about, and then we'll get out here. Oh, we got out here quite a bit. Cool. And this is actually getting to the heart of chapter 3. It's one thing to be able to graph individual points. But now, bless you, you know where we're headed with this. We want to graph points that happen to line up perfectly on a line now, right? And they're related to some equation. So let me ask you this. Can anybody tell me, bless you, it's a movie Contagion. Can anybody tell me any possible answer to this? Now, an answer to this has to have how many parts? 2 parts. You can't tell me 7. What? I like it. So if x is 5 and y is 2, that works. Let me just make sure you guys are with me. Do you see that?
Yeah.
All right, cool. Now, if you've done graphing before, you've maybe never done something quite like this, and we're not going to do it exactly like this when we go to do it for real. But I just want to start with this idea. 5 minus 2 is 3. So if I make x 5 and y 2, beautiful. What about if I had a 4 here?
4 and
4 and 1.
1, yeah.
What if I had a 3 here?
0.
Beautiful. What if I had a 6 here? 3. Do you see how the basic idea is, what's really the relationship between all these points? When x increases by 1, y increases by 1, doesn't it?
Yeah.
Always. It has to. The only way to have the same difference between two numbers is if they stay the same distance apart. So if this one is 1 bigger, this one will be 1 bigger. So visually, what will that mean? What happens when I graph these points?
You have an arc.
6, 3, 1, 2, 3, 4, 5, 6. Alright. This is always the funnest part, just sitting there watching me do this. Okay. So 6, 3, where would that be?
3.
Good. Over 6, up 3, 11. And what about 5, 2?
5.
Over 5, up 2. So see how it changed by 1 and changed by 1? 4, 1. 3, 0. And see, that's my line there.
Yeah, negatives. It would make an arc.
Because this would be weird for me to say, but do you see how this is still valid? What if this was 2.5? Let me not go too freaky. What if this is 3.5? What would have to go there? 0.5. So, I mean, do you see how I can find specific, easy to get answers, plot them, and then what do I actually do by connecting them now? I'm saying everything that line goes through. Here's the cool thing. Here's what a line really is. Every point that line goes through, not just the ones you plotted, but every freaking point. Like that point, and that point, and that point, and that point. You know, they're all answers to this. Because 7.2 minus 4.2 works, right? Infinite number of things work. 100 minus 97. So forth. All these billions of things work. That's what happens. That's why we graph things. Because if somebody said, what's all the answers to this? How long would this take? Forever, and more than that. And then how long does this take? Pretty damn quickly. And then I say, well, that's not the answer. Well, go find whatever answer you want. Keep going that way, keep going that way. Find the answer you want. Leave me alone. I'm done. I gave you all your answers. Right? Cool. So what we normally do, you guys might remember this. How are we feeling about this graph and stuff? I mean,
Good.
I can understand as a student, if you're told to do something and you don't understand why you do it, you're that less interested in doing it. You know, there's a freaking point. It's only going to be one problem that 10 cares. But there's a huge reason for doing this. What we normally do is we have a problem like this. Does it look more familiar?
Y equals mx plus b.
And don't think about that, we're not quite there yet, but I'm sure some of you guys remember the good old mx plus b form, right? But if you haven't heard of it, it's been a while. We're not there yet. But we can actually, for this, we can make an xy table. And this is where we collect points. So like we did here, we made a whole bunch of points so we can graph them, and then we connected them. And how did I know it was a straight line? Because everything's to a first power. You know, I want to make sure you guys understand. If anything was to a second power, something would curve somewhere. Then it wouldn't be a straight line.
That's it.
Everything's to a first power here, right?
Yeah.
So I know it's going to be a straight line.
You lost me on
If there was a square there, we know it would be, wouldn't we know it would be like a parabola?
Yeah.
I'm sure most of you guys know it would be like, it has to curve then. The minute the power on a variable is not 1, it's something else. Anything else. Except 0, that would make it 1. Anything other than 1 or 0, then it's going to have to be curved somehow. A cube is going to look like this. Fifth power is going to look like the same thing, right? The minute, or 1/2 power is going to look something like a freaky little sideways parabola. They're going to have some kind of curve to it. The fact that it's to a first power tells me that it's a straight line, right? That's to a first power. That's to a first power. It's a straight line. How are we doing?
Good.
And actually, I don't. Well, let me not freak you out too much. So now what I can do to finish this out then, to make a few points to graph, is I can just pick values for x. Because what's x allowed to be? Anything. But the minute you make x something, y must be a specific something to make this work, right? That's the idea. So if x is 0,
Y is 2.
y is 0 plus 2, yeah. So y is 2. If x is 1,
3.
y equals 1 plus 2, I get 3. If x is negative 1,
1.
y equals negative 1 plus 2, get 1. So forth, right? So what points have I made so far that we can graph? Good, I made the point 0, 2, 1, 3, minus 1, 1. I love it, all right? So take a second to try to plot those and see if they line up into a straight line. If they don't, you know we made a mistake somewhere.
So a homework question would be like plot.
Yeah, I'd say like use a table to plot this, right?
To how many?
At least 3.
At least 3.
Yeah, when we start getting into ones that curve, we're going to do at least 5. Because we got to find where they kind of turn, right? If it's a straight freaking line, I really just need 2. The third one is just to make sure I'm on the right track. Totally. Obviously, I'm not going to pick 18 billion or 1.7, but you know, I'm going to pick around 0 normally. I pick some negatives and some positives and 0. That's normally a good idea in general to get a feel for where this thing is going.
We could easily do it.
Yeah, could have made x2, negative 2, you know. So let's see, what we got? 0, 2 is where? Zero, 2. So I go 0 this way. I only go up 2. 1, 3.
1. And then up 3.
3. Negative 1, 1.
Negative 1.
Back 1,
Up
up 1. And thank God they do line up. So this point here, what does it do? That point right there, we don't know what it is exactly, but what do we know it does?
It's part of the line.
But true, but what does that mean about it in relation to where we got that line from? What does that point have to be able to do then? It has to make this work.
Yeah.
Whatever it is, whatever the point is, if I plug it in, the x piece and the y piece, it better work. That's what it means.